The lava system is a CAD/CAM procedure for manufacturing all ceramic crowns and bridges for the anterior and posterior region. The frame ceramic is made of zirconium oxide. It is supplemented by a customized veneering ceramic. Manufacturing the frame begins with non-contact photo-optical scanning of the model with the lava scan. In this, the cores and region of the connecting part are scanned several times from different sides. The scans of different model positions are the basis for calculating the three-dimensional image data. Changing the model into the various positions should not be observed under normal circumstances because the device must then be closed. The byte record is also scanned because it gives important information for shaping the frame. To later be able to treat the alveolar crest separately, a series of scans is also made of the alveolar crest, but without cores. The subtleties of the scanner adjustments are not what this report is about. How to adjust contrast or move the core into the right position are examples of simple and easy-to-learn operation. The three-dimensional image is formed layer by layer from the scanned single images in the computer. Based on this image, the bridge is later constructed and the cutting paths calculated. The preparation limits are automatically determined and displayed. The lava scan software is so well developed that interventions by the user are hardly needed if the crown margin is undergrooved properly. Now the cores, gingival section and byte record are present as individual digital image sections. The computer image can be freely moved in the space so as to control construction from all sides. The data for the connecting part is already prefabricated and can be retrieved from an image library. The pontic is freely scalable, which means it can be enlarged, widened, made higher, in short, adapted to the available space and required shape without restriction. The joints of the pontic to the crowns are likewise already prepared. The right position and cross-section are established with keyboard and mouse, in this case 9 square millimeters, using the software. The program reports every time the calculated ideal size falls short. The computer also supports optimal alignment of the bridge to the cutting axes. Now the positions of the holding bars are determined. The ready-cut object remains connected to the bars until cutting with the zirconium oxide block is finished. All relevant material, for example on material or cutting strategy, is included on the blank in the form of a barcode. It is recorded with the scanner. If all data is calculated for cutting, it is automatically transferred to the cutting unit lava form. The frame is cut from a pre-sintered zirconium oxide blank in a chalk-like green state, from which the machine can process up to 21 consecutive pieces thanks to the magazine. Hard metal tools are used for cutting. They're very long-lasting because zirconium oxide that's only pre-sintered is still relatively soft and therefore easy to cut. The cutting tools used are changed fully automatically. The cutter is checked for wear and tear with each change. Cutting consists of rough filing and smoothing. With rough filing, a high tool feed can be used. The cut object accordingly emerges quickly. The feed is reduced with smoothing. That results in a smooth surface. The shrinkage occurring when the bridge is sintered through was considered when the cutting paths were calculated. As a result, a very good fitting precision was achieved. The marginal gap is 50 microns on average. Single crowns are ready after 35 minutes on average, with three-part bridges finished after 75 minutes. The connection bars are removed and the anchor points and possible sharp edges rounded with rubber polishes. A special feature of lava is that the frame, not yet sintered, can be dyed with one of 7 lava shade liquids. The colors are associated with the Vita Classic color scale. Instead of being pure white, the frame is given a basic color matching the desired tooth color. Immersion takes 2 minutes. After the drying period, the frame is sintered through in the sintering furnace lava therm at 1500 degrees Celsius. Sintering takes 7 hours. Only after that has it reached its full hardness of over 1000 MPa, an extremely high value. It is well over the hardness values of full ceramic systems without zirconium oxide ceramics. At the same time, the lava frame achieves the natural translucency of dentin. Now the lava frame just has to be veneered. For that, lava ceram is available, a veneering ceramic tailor-made for the heat expansion of the lava zirconium oxide frame. The lava ceram assortment is orientated to the Vita Classic color system. Along with dentin and enamel mixtures, there are intensive and effect mixtures to enable natural characteristics to be recreated. Layering begins with modifiers. Then come dentin, enamel and transparent mixtures as with any other veneering ceramic. Because the frame color already has the right dentin color, there is no need for opacers. This bridge is convincing not only because of its attractive modulation and color coordination, but just because of the translucency characterized for lava. With that, you get a perfect match to adjacent teeth.